I hope this is Neependra, and I welcome you for our workshop on eBPF and Cilium. That is what we're going to cover today. This workshop is part of the KCD Bengaluru. As you know, that we are doing an event, in-person event on 2nd and 3rd of June in Bangalore, and we have been doing like these workshops over the last few weekends, and then this is. I believe the 9th workshop what we are doing, and then post that there would be 2 more workshops happening in the next weekend, and then of course we'll have the full event days actually in Bangalore there. All right, so yeah, so let's get going for today's workshop then. Let me just start sharing my screen. Okay. So I'll just do a quick intro about myself first, and then we'll look at the topics what we are going to cover. So my name is Neependra, founder of CloudRigger, and have a decade, access of close to 2 decades of experience in the industry. Started CloudRigger in 2015, and before that I worked over a decade in different companies, primarily with Red Hat though, and have experience as sysadmin, support engineering, file system, kernel development for engineering. And in 2015, I wrote a book on Docker and then published in Kubernetes course for the CNCF on EDX, which was taken by more than 200 users across the globe. And then I'm also one of the organizers of the KCD Bengaluru, which we talked about already. So this particular workshop has 2 parts to it. One is covering about eBPF and its use cases. So this presentation I gave for some other topic, some other place, but that's okay. We would cover this particular part here. And then second part, we would talk about the Cilium and the security aspect of the eBPF there, right? So yeah, let's kind of dig deep into further. So so the eBPF has come from the BPF, what you see on the screen. The BPF is a Berkeley packet filter that was kind of developed long ago to kind of just look at how does the network traffic, or how to kind of look at the information about the packet which is going through and throughout our system. That was what people have built earlier, BPF, and if you would have used the TCP dump, I'm sure you would have used TCP dump. The TCP dump was kind of built on top of the BPF. The software was what was there earlier. So the BPF is kind of implemented as like a think about as a virtual machine in the kernel layer itself. So we know that for every OS, be it Windows or Linux, we have user space, and then we have this kernel space part of it, right? So like user space is like whatever you see, look and feel, right? You kind of like open an editor, you open a browser, that all goes in the user space. And then in the kernel space, we have the drivers and which have access to your underlying storage network and so on. So for example, when you are reading or writing a file, you would kind of just say file open and file get opened there. But eventually that file is residing somewhere on the hard disk. So your user space program, which is like your editor, sorry, I'm getting an echo as somebody is, I don't know what happened. Yeah, okay, it's fine. So please mute yourself if not. Yeah. So yeah, so let's say if you kind of open a file and you write something, that whatever you're doing, right, that actually need to be put on the disk, right? So the user space program would somehow kind of go and talk to the kernel, and then kernel is going to actually interact with your hardware, hard disk, whatever you have, and then put the content on the hard disk what you have there, right? That is how things works there. So now what happened is this BPF program was kind of put up in the kernel, and then and it was implemented like a virtual machine. So though it's like like you may get surprised, but it is like think about it's a a very minimal virtual machine implemented inside the kernel that was used to kind of look at all the packets what has been coming to the network layer what you had. And that is how the BPF program was able to kind of read all of the packets, and then you can find out the information about it and so on. And then, of course, you can put that information in the user space where you can look at how the packet is flowing in terms of the end user view perspective. But it was implemented in the Linux kernel itself. That was how it has been done. That was BPF. So from there, we kind of move to the next level, which is ePBF, which is Extended Berkeley Packet Filter. Though you may think that, okay, now it was previously used only for the network, maybe extended means that I can look at the network in a bit more detail, but it is more than that actually. So now, ePBF is kind of not just the network thing, but you can do a lot of other things on top of it. So if you are referring to somebody refers that BPF or the older version. So currently now what is happening is people just call it BPF, and then you assume that it is going to be eBPF only. So somebody want to really refer the older version, or they call it as classic BPF. That's how you can think of, which is the older way of doing things. But with the ePBF, we can really do a lot of other things. We can put our hooks onto a journal events, right? So it is not just about network anymore. It can be done for many different things there. So we look at as we continue, and it can filter out, it can do the processing in terms of both user and the kernel space there. So eBPF can kind of not just meant for the network, but it is for your memory, it is for your the storage things, it is for your network, of course, then it is for your all the kind of drivers and so on. So eBPF really kind of extend way beyond just the network. That is just you have to kind of make into understand that particular part. It also have a concept of maps, which I'll talk about. So again, ePBF is going to be implemented at the kernel level, and it has a very kind of a robust and very dynamic way of interacting with your user space there. So, for example, when you look at the packet, or let's say if you look at the storage performance data or whatever looking there, it will share with the user space thing, because there only I can show it to the end user. That is being done with our map. So I'll talk about this thing further. Any questions so far? Okay. So what you see on the screen, this ePBF is getting attached to different things, right? So now what you can see on the screen here, you can see here it is getting attached to your device drivers, block interface, volumes, file system, TCP, IP, virtual memory, system calls. Then you have this scheduling, CPU stuff. Everywhere you can think of, and even the user space also. Everywhere we can now put our probes for that. Now let's talk about one more thing before we go forward. If you have done the Linux kernel development, right? So not sure how many have done that, but the Linux kernel development is a long, you can think of if you want to put your software, let's say you are building a new network card, for example, right? You come up with a come up with a kind of say hardware which is completely new, and now you want to make sure that your driver is available inside the Linux kernel so that everybody can use it, right? Now, as you start implementing your drivers for the Linux kernel and so on, it may take up to years to get into the mainline Linux kernel. And that way, kind of people get frustrated kind of a thing, right? Because today you want a certain feature on a kernel, but you have to wait for months or for maybe years just to get your feature in. Because Linux kernel, let's say, journal is being used widely, be it in your mobile, watch, aeroplane, wherever it is, right? So it has really breadth of kind of connectivity or different what do you call it? Different support for different variety of hardware, right? So when you kind of start implementing that, software, it may take some time because everybody should have approved it. Then it has to be tested and all those things. So it's not very easy thing to put something new inside the kernel. And that is kind of one way it is good that it is slow, but I mean in a way that it is perfect when it's going in. But on the other hand, as a developer, you may feel frustrated. So you need some way to kind of extend your kernel on the fly. And there used to be like, I mean, they're still there. There's a way by which you can insert modules on Linux kernel on the fly. That is always there. But kind of you want to kind of put these kind of probes and do some of the other kernel changes. That is where eBPF can become very handy because it can update your kernel on the fly. So let's say if I'm telling you, I want a kind of a say function, or I want to kind of connect or collect the data. Let's say I want to say when I go to a kernel function, let's say I'm doing a write function, right? And now I want to say when I'm entering into the write function, I want to see the time and in my given program. And when it came out, right? Once writing is happened, I want to see what time it is, right? So you want to collect the difference when the system call or the write function has been called and when you got the result back. Now, putting those kind of probes on the fly is kind of become very easy with the eBPF part. And that makes the monitoring and the observability part much more simpler, right? Because you can exactly know when the system call was called and when it kind of finished, right? And then you can do all of these things at random in any function of the kernel. So that way, your power goes as a developer or as a kind of somebody who is responsible for system goes way beyond what you can think of, right? And that is where, if you know that, right, a lot of these distributed systems, and then when we do, I'm sure that you would have seen some of these Netflix, not movie, but their case studies, right? How they kind of scale to the large number, how they are monitoring the system. They have been doing with the help of eBPF there for a while. So, yeah. So in a nutshell, eBPF can be attached to any system call or any function you can think of in the kernel. And that way, it would make your debugging and monitoring and tracing much more simpler. Hope that makes sense. There are use cases of it: networking, security, and observability, because what I discussed already, because you can hook the custom functions or custom data at any point of time, that would make things faster for you. Okay, now let's understand a bit how does this eBPF work. So before I go, I just want to trigger a lab so that we can do the hands-on lab. So, you may have saw that lab earlier, but you can do these hands-on labs as we continue on our session. So I'm just going to go to my Cloudica's website, and we have for eBPF. So I'll give this link on the chat, and you can actually open that link and just trigger the lab. I'll just share the link first. Where is the chat? Yeah, okay, fine. So hope we can open that chat, that link, what I've given. And here, again, this is a similar content, what is there. I'm just going to trigger the lab here, and this would set up the environment on which we are going to do our hands-on with the eBPF. Let it happen. Meanwhile, I'll just go to the content part, what we have. Yeah. Okay. So how does the eBPF works? What we are going to do is we are going to put up our request, whatever the request or whatever the things we want to trace and put a probe on and so on. We would do it from the user space. So, for example, when I'm saying that I want to put a probe at a given function, so from the user space, like because I would type, right, or from my editor or whatever I would do, I want to insert that particular thing into my kernel, right? So didn't I share it earlier? This link, I did. Oh, I should share to only on simple. My bad. Yeah, sorry about that. Yeah, please open that link. Yeah. Okay, so let's go ahead. Um, yeah, so now let's understand how we are going to put up our programs or put up our custom functions into the kernel. And that we do with the help of something called as bytecodes. So think about these are nothing but your code assembly kind of a thing, right? That you are actually generating the low-level code, and then that low-level code need to be somehow get inserted into the Linux kernel, using which I can collect all of this data. So what happens is we generate this bytecode, which you can think of like near assembly code, what is required. Then we are going to call this function called BPF. So there's a system call. So what I mentioned earlier, that there is a user and a kernel space. When the user space want to communicate anything with the kernel, it mentions or it kind of does with the help of system calls, right? System calls need to be sent from user to kernel space. And that is what is happening even in this particular case as well, that whatever the bytecode we are generating, we would use the BPF system call, which is a special system call that would kind of make that assembly code what we have been writing into the kernel. And now once it is in the inside the kernel space, what we do is we verify it, because what's going to happen is if there is something wrong in your bytecode, it can actually break your entire kernel. So we need to be very careful that it is not happening. That is where we have this verifier, and this verifier makes sure that whatever the bytecode you are inserting, that is not affecting your kernel in any way. So there are some checks are being put up there, and those checks guarantees that whatever the code is going in there, that is perfect, and that is not going to break my kernel. That is the verifier's job. Now, after the verification is being done, then what we do is we do it with the help of JIT, which is just-in-time compiler. That basically, depending on your depending architecture and so on, and some other details, it would insert into the BPF that I told about. The kind of it kind of creates that a very minute virtual machine in the kernel itself. So it basically get into the kernel with the help of a virtual machine creation inside the Linux kernel. And then whatever the event you have mentioned, right? Let's say you said that, okay, I want to attach the function on a kernel or either space or on a network stack or on any trace points. So there are events you mentioned, so that you want that bytecode to be attached again a given function or either space program and so on, that you attach to it. And now whenever that particular thing is being called, you basically do the data collection part of it. For example, as I mentioned earlier, right? When I go into a function, I want to get the time in. When I come out, I want to get the time, right? So I want to collect. In the meanwhile, I can also say that when I'm going into a function, I want to collect what were the arguments to it, right? What were their values? So even that kind of information you can get with the help of eBPF, right? So think about in a way that you are sending a packet from one machine to another machine. Like think about Kubernetes terms, right? That one pod is sending the data to the other pod in the other machine, correct? So when the packet is kind of transferring over the network and it hit the eBPF on the other point, right? eBPF on the other point, we can figure out from that particular function itself that this particular packet was meant for Kubernetes pods and so on. All this data set I can get it from there, and that way I can make further decision for my networking and all that stuff there. So because it is like you have an eye in the kernel and you can see everything what is happening, but in a controlled way, of course, that you're not kind of going to break something, but in a very controlled way, you have kind of your eye inside the kernel, and then you're kind of seeing what is happening, and then because you can see, you can observe, you can report back to it. And for that reporting back purpose, we have this maps thing. So eBPF then kind of have these maps, and these maps would have the data what I want to share with the user space there. So on the user space, we'll get like the whatever the data in a way that we can kind of say grasp, or we can kind of understand, right? Like I need the data in terms of the way I can read it. I can do a like average of it and all that stuff, right? that data would come into my user space, and I can do further thing on top of it. Any questions here so far? Okay. Fine. So now, of course, writing the bytecode by yourself is going to be very challenging. You are not going to sit down and write the bytecode, the assembly code on your own. So what we have these different front ends, and these front ends are going to help me generate those bytecodes in a much more simpler way. So there are Go libraries, C libraries, and so on, which can help me generate some of these bytecodes in a very effective way, and then I can then just continue further. So let's kind of try to go back and okay, and then other than that, these are the different kind of maps what we can have. These maps can be array, hash tables, string buffer, stack trace, and so on, which I can send from the kernel space to their space with the help of maps. That is how it is being done. Let's go ahead and try to do some of the hands-on here. And you can do along with me, as I mentioned earlier, if you trigger the lab, you would be able to perform all of these things there. And I'll talk about all of these things anyway, the security aspect, networking part as we continue. But let's look at some of the examples here. So what I'm doing here is I'm going to run this particular program, which is called BPF trace. And I told you it is, where did that go? Yeah, it is one of the front end, which is there. So, so it's a high level tracing language, which can help us perform or kind of put these traces at different point of the time in the kernel. So let me kind of install this particular package first. So, oh, sorry, I need to first install it. Yeah. Now, what I'll do is then I'm going to put kind of a say a system call by count. So basically, let me show you what I mean by that. So now I have put down I want to kind of collect all system call that has been called as I'm kind of doing something, right? So let's say if I go and perform different operation, let's say if I do date command, or let's say if I just open a file here, correct? So now when I have done these commands, and then I say Control C here in the previous one, you would see that these are the system calls that has been called in the time frame, in the time in which we ran this particular program. It kind of collected how many calls has been called by the given program, as you can see here. So as you can see, this cat has called like the 48 system calls, and just called 210 system calls, and so on. This kind of thing, it has given me in a very simplistic way, right? In a very easier way, right? So now let me actually look at other programs so that I learn a couple of these things so that it becomes much more clear what is happening. So I run this program now. So now let's say if I type date command here, cat. So you can see here what is happening now. It is able to collect the data, right? So when I kind of ran that cat command here, the cat command is being noticed here. So think about you are running this particular function or BPF trace in an environment, right? And then somebody comes and try to opens a file. So again, let's say if I'm putting up a thing on, let's say again cat/etc password file. As you know, that password file should not be read by anybody in general, right? But somebody is doing it, right? So now if I have been in this program, you can know, I can get a notification kind of a thing, right? That somebody actually opened this particular file for me. Now you can think of that this is a very simple use case. Now, if you try to kind of extrapolate it further, right? This can become a very good security feature, right? That you are running different containers, different programs and systems. And as soon as somebody opens this particular file or any other file which you want to kind of control, right? And then you get notification of it, right? That hey, somebody has opened this particular file which was not supposed to be read by anybody, or like only by the admin. So something went wrong with it, correct? Let me go and check it out. So these kind of things become very simpler if we use BPF. Are you guys able to perform these things along with me? Anybody doing it? Yes, no, okay. One person. What about others? Okay, fine. If you can do it along with it, it's better because you can do all the hands-on. Okay, so now if you look at this particular program, right, which is just called, right? So I just kind of figured out the location of the particular program. So because we installed this BPF trace package, right? From that package, we have got these different programs. So I just figured out the location of these things. So I'll just run this command that give me the location. If I just open this particular file, right, you can see here it is kind of just have a very small stuff, right? Nothing much. It's just kind of putting that begin that what I want to kind of print it out. And then you can see here, it is saying that you ret probe, which is nothing but put a probe on the user space return function. So what is saying that whenever I'm putting, when I'm calling the user space function, return of that, put this hook there, kind of a thing, right? So that way I'm able to kind of collect this data. Another example I have here is, let's say, it is for the trace new processes by the exec call. So if I am running this program here, and whenever I'm going to create some child programs, let's say if I open up bash inside the bash, let's say I'm calling the bash here, right? So you can see here that would come here, right? Bash has been come, and then there would be other programs which are calling this function of exec, right? So all of these things are getting collected on my screen, or of course on my program where I'm collecting it. So that way, it kind of help me trace all the new programs which has been created on my environment. And the next one here is the trace TCP active connection. So now if you want to figure out how many active TCP connections you have, again, look at the use case there. Let's say somebody is doing the hack on the system, right? And you want to figure out who that person is from where the person is coming from, correct? Or if you just see that I'm not expecting any connection from that particular IP, correct? Because let's say you configured a firewall in an environment and you allowed only the connection within the network. But now, by mistake, you may have left a rule and somebody remotely can connect to your system. So how would you figure out? And if you figure out what you will do? So that's something which we can kind of figure out with this particular, program here. If I run this, open this program, this is going to put up what do you call, say, the information on the respective TCP connection. What is kprobe here? Kprobe is nothing but your kernel function probing. So it says that whenever the TCP connect function is being called in the Linux kernel, do all of these things as well, what I'm saying. So as you can see here, it's going to print out that eventually who connect and where to connect and all that stuff. We'll see that. But I'm just trying to tell you that with this particular mechanism, I can on the fly get this particular hook into the kernel function which I may be having there, right? So if I have this particular program now let's see if I go and connect or make a call, right? Let's see if I say ping cloudiga.guru, right? Ping may have failed, it's okay perfectly, but I think I say control C here. No, it is not connected. So TCP is not okay. I just did on the TCP, I did the what you call, say, the ping connection. So I just need to make a TCP. Let's say if I just give me a minute to reconnect. Yeah, so let's say if I do let's see. For now, I just do local host only, but I can do some of the remote machine as well. Yeah, so I did the loopback connection for now. Yeah, you can see here, it has been triggered, right? This connection has been triggered between the source and destination. So of course, I'm doing locally right now, but let me make a connection to some other machine as well. Let's see. I don't have the path for the instance which I have. But let me just initiate this connection. Let's say that goes through. Yeah, so it's going through, right? As you can see here, as I made a connection here, right? You can see that it is being recorded here. Now again, these things can become very handy. So if the same way if somebody connect to my system, I would be able to understand who is coming from and where, right? And which port they are consuming and so on. So that way, again, I have put down a hook on my TCP connections or TCP connects, and that way I can figure out the details internally there. Hope this makes sense to all of you, what I'm just kind of mentioning here. Any questions? Okay, so far so good. Okay.
So this can be used for the monitoring as well, like stats we used to use right earlier. Will it replace that kind of tools? Can be used for the tracing and monitoring.
Yeah, so basically, I mean, they can replace or they can use it internally. So see again, this particular software, what you have is a feature of the Linux kernel, right? And whatever the tools have been there earlier, right? Now they can take the functionality of this particular feature and make it more powerful. So it can replace in a way that there will be new tools who can replace them, or other way, there would be tools which would internally start using it in a more effective way. And that way they'll become more powerful as well. So if you have heard about Falco, right? Falco was the project from the SysDic, right? As you know. So Falco used to do this, the kernel, what you call say um, the kind of security measurement and all this stuff with respect to their kernel specific calls there. But now they start using eBPF because it has become default and is much more powerful than the earlier one. So what I was saying is, yeah, so some of the new tools would come up, or whatever the tools, the names you have, right? They'll start consuming it in a more effective way. So you said StatsD, right? What did you say? StatsD.
Yeah, right.
Okay.
Right, exactly.
StatsD, I think I have used it long back, but let's just check StatsD. So StatsD, right? Is there a program? Yeah, so that's the one, right? Yeah, so I'm not too sure about that right now, whether it is using it or not. But yeah, I think you will see that either these will become more powerful, or there will be new set of tools which will come up. Yeah. Okay. Any other questions? Okay, fine. So that is there. Now, similarly, if I continue further, what are there is there are different programming languages which also have this functionality or kind of say modules to implement eBPF along with it, right? So for example, here's an example of the Python program. So you can actually write a Python program which is going to consume the BPF functionality, and then you can get more information just writing the Python program, because as I said earlier, it's difficult for you to write this bytecode on your own, but the modules for different languages can help you do it as well. So what you see here is a Python program in which what we are doing is we are attaching or we are kind of importing the module called BPF from this particular package of Python. And then what we do is we define a function here, which is we define the prog function here. And what we do is whenever I'm just creating a function right now called hello. And then whenever hello is being called, I'm just going to echo out this thing. Hello, KTS and cloud community. I'm just going to print this out. Now, what I'll do here is with the Python program, I'm just going to mount. So I have defined this prog as a program which I want to call if something happens, right? So what you are seeing here is we are kind of calling this function here. So we're saying BPF. So we're saying BPF function. So we're just defining as a variable there, and then we are saying that attach this program called, so text is equal to program here, and then what we're doing is we're attaching to a clone function. So whenever the clone happens, so whenever a child program gets created, we attach this hello function as a return thing of that. So as simple as is it that we have defined our functionality, what I want to get as the output of it, right? So you are saying that like here we're saying that just print out hello world and kind of stuff, but you can think about, you can say, give me all the arguments or give me all the current time when it's entering and exiting there and so on, right? So I have attached that particular hello function with the BPF function call here, what I'm doing here. So in the Python language here. And now whenever a child gets created, I would get the data on my screen there. That is as simple as that. So you define a function and then you attach to a system call. When it's called, get called, give me some data as a return value of it, right? So let's try to do this hands-on lab as well. So I'm just going to install some packages here. Yeah. Sorry, I'll cancel it. Yeah, this is installed it. I'm just going to call this Python function here. So I just want to have this Python file, whatever is there. Right. Give a name, whatever you want to give. Got my content in here. And then I just run the Python program as it is, whatever general Python there, Python 3 and hello. So now whenever a child program is getting created, so whatever I do, whenever I say, let's say, create one more child program here, or let's say when I do a cat of etc, or whatever, whenever the function is being called, this is going to come up on the screen for you. So as you can see, whenever a child is getting created, I'm going to get this output on the screen. Correct? So that is how we can kind of get my data back to the user space whenever something happens in my kernel or in the user space there. Hope this makes sense. Any questions? So what are the other use cases you can think of? Sorry, go ahead.
Yep. So this guy, it is attached to the kprop, right?
Yeah.
And it is actually calling the clone, which is indirect like the exec.
No,
Right.
so what is happening here, it's not calling clone. So what we are configuring here is whenever clone is being called, right, like this. So what we are saying is whenever the clone is being called, call this function as a return value of, or the return thing of that. So clone is getting called as it is in the kernel, like whenever it's being called. What we are simply saying is whenever clone is being called, call this function as well along with it, which is the pro which we have put up here.
Okay, so it is attached to the kprop hooks, which is available.
Yeah, of course. So that is what happened we saw earlier with the thing. So it's like that. So this is what we are saying is in the Linux kernel, there is going to be a clone system call or a clone implementation in the kernel. Whenever that program is being called, whenever you do creating a new child program, call this function along with it as well. Make sense?
Yeah, thanks.
Yeah, so there can be probes, and then what I mentioned is there can be user space probes and so on. So you can put at different levels. So kprobes is one part of it, then you can put at user space probes as well and so on.
Yeah, clear. Thanks.
Okay, other questions? Okay, fine. So this is part one of the things. So now, where all you can think of BPF can be very useful. Now, we saw, I mentioned about some of the stuff already, but where do you think that it can play a very important role as in the current scenario, what you see, right? In whatever you can think of in the industry you've been working on, right? So where all you can think of eBPF can be useful. Put on the chat, that would be helpful. So I'm already put down some of the stuff on the screen, but in your current scenario, what you are doing, right? Where do you think that eBPF can fill in the gap there? Okay, why? Okay. Fine. So let's kind of carry on. So now what we'll do is we will look at some of now we will move to Cilium part of it. So observability without sidecars. Yes, that's true. That can be there. So that is good use case what you mentioned. Any other thoughts in the idea? What is on the screen, which we'll talk about in Cilium as well as we continue. What you see on the screen is I'm sure that all of you have been using Kubernetes for a while. So in the Kubernetes, we have kubeproxy, and then kubeproxy implements the traffic which comes from external world to the inside, as well as it also implements when you hit a service layer, it will send the traffic to your respective pods behind the scenes. So you have a service endpoint. When you service endpoint, the traffic would go to the underlying pods as well, right? And now that has been implemented with the help of IP tables on the Linux, what you have there, right? Linux thing, right? So now you can think of, so when it implements that particular part, so when you hit a service layer, from service, it goes to the pods. It kind of performs these different IP table kind of what you call functionality there, like that mangle net, then there is a forward, masquerade, and all that stuff will do. And then eventually you kind of go to underlying pod here. Now there are multiple kind of hops, or not hops per se, but multiple IP tables steps are required to go from your service to the pods there, right? Now, this is perfectly fine for minimum or kind of a less number of applications, but as you scale to a lot of applications, a lot of pods you create, right? This kind of become a significant performance issue for you. And we can kind of, if you use eBPF, what can happen is your eBPF at the card level itself. So when you have a network card, you can attach eBPF there because it can attach there, and it can have a view of the entire thing. So it will have a view of the pods as well as the service endpoints. So now all of these things are gone, correct? And that would make your network traffic to go much more faster way. That is the powerful or the power of eBPF, because you're going to get rid of all of these things. And when you multiply by the number of pods you're going to have, this is going to have a significant impact on your performance of the network and so on. And that is why it is very popular, right? Because as we know, if you save latency, if you kind of latency is less, right? You are willing to pay for the kind of what you can say the premium for that, right? Because something is very fast. Think about, we all want things to happen very fast. Nobody wants to wait these days. So all of these underlying things would make things very fast, and then eventually it kind of improve the performance of the entire application what you may have in your disposal there. Okay. Okay. So any question about eBPF before we move on to the Cilium part of it? Okay. So let's kind of jump into the Cilium part of the part of this thing. So now, what is Cilium? Let's just understand that part. Okay. So now, once you have deployed our applications on your environment, be it in your Kubernetes or be it other anywhere environment, right? What you would want to have, you want to have you will care about, right, whether your applications are reachable or not. So when you deploy your applications, you would worry as a SRE or the DevOps engineer, right? You want to make sure that your applications are available all the time. You have no latency kind of to access them. My website is very fast for my customers. Am I able to distribute my traffic to all the replicas? That if you have running 10 replicas of your app and you want the traffic to go across all of them in a way that not one of the pod is kind of getting all the traffic from the endpoints from my customers. Are my applications going to connect securely? So when I talk, so as you build microservices, right, we'll have different things, right? We'll be having, let's say, payment, order, and other services there, right? We want to make sure that all of these things are securely communicating. Now, one way to do it is you can, of course, implement the security thing on your own. Let's say when I talk from order to payment, I implement the secure connection between them manually, right? Or is there a better way where I can guarantee that if I have deployed it, they'll be communicating securely among themselves, right? Then how do I find a bottleneck? So if something is going wrong in my environment, how would I find bottleneck and where it is exactly, right? Because in microservices, the traffic is going random or in a way that anywhere it can go, right? And something can go wrong at any point of time. So how easily I can find out where the bottleneck is. So that is something which I want to figure that out. And then, are we necessary? Yeah. So basically, it should be it should not be having that if my application don't require a given access, I'm just giving unnecessarily to it. Let's say if a user or if a user don't want to let's say if a user just want to take a backup of a system, right? He should have permission to just take a backup. You should not have permission to create a user kind of a thing, right? Similarly here, when you're deploying your applications, they should do whatever minimum is required for them to be done. They should not kind of try to do more than what they're supposed to be doing. So how I can kind of take care of all of these things, because deploying app is one part of it. After that, only the challenges comes into the picture, right? Because when you run production, when you have these issues, somebody hacks your system. I mean, it should not happen, but it kind of it can happen there, right? So how do you make sure that you don't get in a situation like that, or if you get in, how to come out very easily, correct? So that is where we want to kind of get there. Now, if we talk about in terms of applications, right? These applications are primarily available over the network, right? Because only then we can reach to them, only when they can communicate to each other. So we kind of communicate with our applications by this something called as CNI. Now, what is CNI? CNI is a container network interface. You can say as a standard what community has created, using which we have a standard way to connect different containers across the network. And there are many different plugins available which kind of help us with this network, right? So I'll quickly go to a different course of ours. Just give me a minute. I just want to, because as we are here, let us talk about that part briefly, not too much. The way it works in Kubernetes is we have this our API server, and then we have this kubelet that kind of creates the pod, and then we have this CNI. So CNI is an external plugin which you have to install. So so what happens is when you configure the Kubernetes cluster, the Kubernetes cluster by default when installed, it does not configure the networking between the pods what you're going to create. So that does not install, right? So as you know, that you need to install some kind of a network plugin on top of the base, especially of Kubernetes. So CNI, which is Container Network Interface, is standard, and there are different softwares are available which can implement the CNI and assign the network or the IP address to my pods and so on there. Correct. So for example, here, when I say API server create a pod, that request go to a kubelet. Now this kubelet only creates the loopback interface. It does not give you an IP address of the pod and so on. It just makes that namespace available to you. And then what happens next is the request would go to the CNI plugin, whichever you have installed, with like add functionality here. And then this CNI plugin is going to look at the configuration, and then this configuration assigns the IP address back to your pods. That is how the CNI things works in an environment in the Kubernetes setup per se, right? You make a request, and then to the kubelet, which would kind of talk to the CNI driver what you have and get the IP address to you. Now, why this is very significant here? Because I talked about already that you don't deploy application in silos; they'll be connecting to each other and so on. And if I can put whatever the hooks I want to put up right at the network layer, it is going to make things easier for me. So Cilium is one of the eBPF-based CNI driver. And then when you use Cilium as a CNI plugin, the feature we discussed earlier, you get it in the Kubernetes as well. Correct? So I want to kind of look at the traffic going on between the pods, the latency, even the other security access that I want to allow access from A to B, not B to A, and all those things, because now the Cilium has that visibility and it is hooked into kernel, right? Along with the eBPF, it can now do all the magic what we just mentioning about earlier, that all of these things are possible because just by adding the right CNI driver, because this CNI is based on eBPF. Hope it makes sense. Then that is why it has become very popular, right? Because it is implemented on top of eBPF. So Calico and Cilium are the two CNI drivers which are implemented with eBPF. So Calico has both the kind of implementation there. They have non-eBPF, I believe, and eBPF based as well. So eBPF, but I think in the eBPF ecosystem, Cilium has kind of got that momentum like the Kubernetes has got in the orchestration one. Correct? So Cilium is an open source software for transparently securing the network connectivity between application services deployed using a container management platform like Docker and Kubernetes, right? That is what it is. Now, why Cilium? It is going to be much more performant, as we discussed earlier, because it's going to be happening. It is going to kind of look at the data even before it is hitting at the upper layer of the, in a way that what we are saying is, the Cilium can actually read the content when it hits at the network card level itself. So even before it hits your other layers of OS, Cilium can understand that from the network packet itself, that where it belongs. And that way, it is going to be much more performant than any other networking drivers there. We can configure better network policies. So when you want to configure the communication happening between two endpoints between two services and so on, so we can build better policies because we have the entire network view. So we can set up transparent encryption. So when traffic is going between the different applications on the same node or different nodes or even different clusters, we can transparently encrypt them. That is again very good feature to have. Then we have cluster-wide policies. So if you have used network policies in Kubernetes, they are typically namespace-based, but with the help of Cilium, we can have cluster-wide policies there. We can configure monitoring, L7-based load balancing, bandwidth management, and so on. So these are the features which you're going to get with Cilium, which is making it very compelling choice of putting it on top of any other CNI drivers what we have on the environment there. Any questions? Okay, so we already understood first of all that there is going to be the network what we are going through on the system. Then we know that eBPF is already there on the system. It's a part of the Linux kernel itself. So eBPF comes as a default kernel feature, as I mentioned already. Now Cilium basically sits kind of on top of that eBPF driver, what you can say there. And then it can interact with the eBPF module of kernel, and then it can interact with the other pods and the network what you may have in the system there. So Cilium can very much interact with eBPF, and through which it can interact with the other apps what you are in the system along with the underlying kernel what you have. So this is the view what has been given to you from one node perspective. So what happens is when you install Cilium, it is going to install an agent on every machine. and that agent is going to help us collect all the data and so on there. Okay. And then once we have the Cilium data, then we can put all of these things on top of it. So once you have a Cilium, which can interact with the underlying pods application, what we have, then with the Cilium agent, what we have, we can do network policy, load balancing, bandwidth, logging and ops, whatever this thing we can do on top of it. Yeah. Any questions? Okay, so before I go for the next particular part, what I'll do is I'm just going to spin up an instance on the cloud so that we can perform the lab. So what was happening is I was trying to do the Cilium lab on our environment, what I just showed you, but because of the interconnectivity between the underlying infra, what we have and the Cilium, I could not actually set up the Cilium on the same instance what I showed you previously. But being said that, I'm just going to show you setting up Cilium from the very scratch, and then we'll give you access as well of this system so that you can also do some hands-on labs along with me. But for timing, you have to kind of just stay with me so that I can just follow along and then give access to you. Yeah. So what I'll be creating a VM instance on the cloud, and then we'll set up the Kubernetes cluster on top of it and then perform the different Cilium-based operations there. So I'll just create the instance here. We can create 1.8 GB of instance, regular is fine. And then how many ports we have? Yeah, not many. So I think we can stick with, let be for 8 GB for now. With my instance. And let's say if I build ACDB collection. Let the VM come up and then we'll look at the next step after that. But let's go back to the slide deck and discuss the other things, right? Did I move forward somewhere? We were here, right? Yeah. I'll put something. Okay. Yeah, so this is, if you look at a very high level, this is how the Cilium component looks like. These are the different nodes of the cluster. So basically, you have a Kubernetes cluster, you have multiple nodes there. On every node, we'll have an agent running, Cilium agent, and they can connect to each other for sure. That's what we have here. Then we have the CNI plugin, of course, like the way we discussed. So of course, we have an agent, and then you configure that CNI driver connectivity with the kubelet there. That is going to be there. Then we have this Cilium operator, which kind of sits on top of the entire cluster and communicate with all the agents what you have. So it is kind of, so Cilium agent would have, think about a local view of the environment, but Cilium operator can kind of look at the entire agents what you have and try to manage them. And there is this key value stored. So what happens is, let's say when I want to kind of put any information like, let's say the configuration of a given agent or the what kind of pods I've been like what are the information in my environment, like how many pods have been used in my system, what are the IPs I have given and all that stuff, right? And whatever the information what is required for the Cilium agent to kind of store, right? Because Cilium agent, let's say if this particular node kind of get rebooted, right? When it comes back again, it has to have the state, right? What kind of the state of the environment I had previously and all this kind of information. So that data or the state of the Cilium agent is being stored in the either in the CRD, Kubernetes CRD, or in the key value store. So that is how the Cilium operator can kind of get the visibility of all the agents, because we are going to have the centralized storage of the agents configuration and so on in the CRD or in the key value store there. This key value store, if you configure, you can use etcd, but you can also use the regular CRD objects like custom source definitions of Kubernetes and store in the Kubernetes native etcd. What are the key value store that is using? You can use it there as well, or you can configure separately as well. So, but in primarily you'll see that it's going to use in the CRD based method. So basically, whatever data you're going to have, whatever configuration of the details I want to have, it all goes in the CRD, and that eventually gets stored in the key value store of Kubernetes cluster what you're using behind the scene. Correct? Then we're going to have something called as Hubble. Hubble is again being inserted in every machine. So Hubble is kind of going to have a view of the kind of packet going in and out of the system. And then there's going to be a Hubble relay, which is sitting on top of it, of all the cluster. And it kind of then try to map the traffic going in and out between the nodes. So for example, if you have an app running on the node 1, an app running on node 2, correct? And you want to say that when the traffic goes from A to B, so A is forwarding is B is kind of dropping it and so on, correct? So when you want to have that kind of picture, you require the Hubble relay, which is on top of the entire environment on entire cluster. Or if you want to look at the local view, Hubble is a local view for you. So Hubble agent again on the same machine, on every machine, the agent is there. You can look at the view, which is, so you think about, you can do an observation, right? You kind of put like your eyes, and then you can see how the data, or not the data per se, how the packets are, same thing, going in and out, and then understand what is happening there. So for example, if I talk to A to B and I can do that, then that particular thing would be observed locally. But then if I want to get a complete view, I'll have a Hubble relay, which is available in the entire cluster. So again, I'll show the demo to you of this as well. And then the UI as well, using which we can kind of look at the entire flow, how the traffic is going from A to B, which namespace and all that stuff. So we'll see that as well. And we know about eBPF already. And then we have the data store, which I mentioned already. That is the state of the Cilium images, which need to be stored at a central place. Okay, so with that information in hand, let us actually go ahead and install the Cilium on the system what we have there. So I'll just get my VM access wherever the IP is. It is here. Yeah, I'm just going to log in here. Yeah, that is there. So I'm just going to share a document with you, which I've been preparing for this particular demo. And if you can follow along, you can follow along right now, or we can do it later as well. Put in the chat here. Okay, so the point or question somebody asked. Cilium agent runs as a daemon set or need to be installed. Yeah, it's a daemon set per se, right? So we'll install as a daemon set, and that will install this thing on all the machines. Yeah. Okay, so I have a script using which I can quickly install the KHS cluster. So I'll just copy this script and quickly just trigger on my instance so that setup is being done. Any questions meanwhile? Okay, so are you finding it useful, or you already knew all of this stuff ahead of time? Are you finding the training session useful or not so far?
Yep.
Yep, okay. Okay, so let it get installed. Mobile. Okay. So let it get installed. That's getting in there. So we got this one. So that the Kubernetes cluster now, we got all the packages in place. So just getting all the images and then set it up. Yeah, it's been done. Okay. So now, as you know that once this has been done, you would see here the our nodes, right? They are in the not ready state, correct? Now, why is that? Because this is, I mean, we're not able to find our kube DNS in the running state, and of course, we don't have configured our CNI plugins right now. So unless you install the CNI plugins, it would not work. So we need a way using which we can install the CNI plugin on top of it. And as we discussed earlier, we are going to use the Cilium as our CNI driver there. So I'll go to the steps which I shared earlier. And then there are different ways by which Cilium can be installed. So we are going to use the Helm way right now to install the Cilium software. So I'll just first get the Helm package. And then I'm just going to add the Helm repo and set up the Cilium on top of it. So as you can see, what we are defining here is we are giving here is Helm repo head, of course. Then we are trying to install the Cilium on the in a cube system. We are then giving that IPAM. So you know IPAM is a thing IP. What is it full form? So missing the name here, but the idea is that it kind of tell the range or the kind of the bucket in which you want to assign the IP addresses to your environment there, right? So IPAM gives you the IP address from a given range. That is the job of it. So we are saying that the IPAM which is going to be used by Cilium is 10.1.0.0/16, which means this subnet I'm giving here, this subnet is going to be used to set up the net IP address for all of my pods there. I'm giving a cluster name here, cluster ID. So with Cilium, we can also configure multi-cluster environment. So that is what we look at very high level thing only. So for example, if we have cluster 1, cluster 2, maybe in different geos or not geos be too much, I think in the same data centers or different regions what you have. You can configure different clusters there. You can identify with different names. And then you can deploy applications which can span up across the different clusters so that Cilium can help us with multi-cluster. And that is why we're setting up different names here. This is I have operator replicas only one. So basically operator I want to have how many replicas that I'm defining here. And then here is one part, kube proxy replacement is disabled. So you can kind of configure the Cilium in different environments or different setup of kube proxy. So I'll talk about this thing further as well, that how we can configure. But when you're installing the Cilium, you can choose to have whether you want to enable it with proxy, with kube proxy, without kube proxy, or completely there are different modes: strict, disabled, probe, and one more mode is there. So based on that, the kube proxy would be available on system or not, depending on what mode you will choose there. And because if you completely use Cilium, it would replace your what you call the kube proxy, and then what I mentioned earlier, right? There are going to be no IP tables picture because kube proxy is disabled, and all the traffic would go to the pods via the Cilium itself. That will make things much more faster there. I'll talk about these modes as we continue. So now what we have done is we have just a way to copy this program here. So we're going to do this, and then we're going to just set up the Cilium in my environment. So Cilium does not exist as we discussed now. It is not existing there. Now, if I look at the pods in my kube system namespace here, the Cilium pods I'm kind of getting up here, and this is running as a daemon set. So if we create a new pod, a new node, sorry, automatically the Cilium agent would run on that new node as well. So just wait for it to get over. So now in the running state. So now if I do kubectl get nodes, you would see that our cluster has become, or the node has become a ready state here. Correct? That is what has happened right now. We have just installed the Cilium on our environment. Okay. Any questions on that? Okay. Now I need to get a Cilium binary. So we have installed the Cilium package. So let me just exec into the Cilium pod, first of all, the agent here. So I'll just do an exec here. So kubectl exec minus IT, which I believe you know how to enter into a pod on Kubernetes. I need to give a namespace for sure. What happened? Did I come out of it? I don't know what happened. So kubectl get pods minus n kube system. Let me get into the pod of Cilium agent here, kubectl exec minus IT. The agent thing, and I'll give the minus n cube hyphen system. What happened? Fine, I think I may need to put minus n before, right? So then it didn't matter earlier, as I recall. Yeah. So I'm now inside a particular pod, and I'm forcing the agent. There are multiple containers are there, but I'm inside the Cilium agent container there. Yeah. So now, if I look at the Cilium command here, so Cilium help. So you can see here there are different Cilium commands I have here, and if I look at Cilium node ls, so it cannot tell you how many nodes are there in this particular Cilium cluster, right? Because we deployed on a single node right now. We just have a single node, and that is what is being shown here, that there is a single node Cilium agent also running, that is running on this particular IP address, and this is the CIDR given for the pods there. Now this is, so I'm, as you know, I'm inside the Cilium agent pod, right? That's what I want to kind of highlight here. Just focus on that. You are inside the Cilium agent pod. Now what I'll do is I'm going to download another Cilium binary here. That is a Cilium binary for the Cilium software management. Let me do that. Because sometimes we get confused here between two binaries here. So I'll just want to kind of highlight that particular part. So here now I have another Cilium binary on my main system, which I have. And if I look at the Cilium --help here, you will see that all of the commands, right, are different than what we saw in the previous one. This is my previous tab in which I am inside the Cilium agent pod. There also have a Cilium command, but for this Cilium command, I have different options here. This is not the same one. But if I go to the other on the host system, there we have different ones. So just don't get confused between the two Cilium commands. What we have, one is for management of the software, another is the agent. You have the commands there. So that's something where sometimes we miss out there. So now I'm on the system here, on the main system, and then what we can do now is if I do Cilium status, you can see it's kind of giving us the status here. It is kind of telling us the deployment information, the DNS information, the number of containers running, the Cilium OK, operator OK. So this command kind of give you what is the state of the Cilium software at this point of time in the environment. Correct? That's something which we have done right now. Nothing much. Now we can check up, or we can check different Cilium resources, what were created, and different CRDs, what are there for the Cilium. So if I run this command, not here. Yeah. So actually, I just rename this particular bash or the master node. So you can see at the bottom that where I am right now, that there's a confusion here. So this is the Cilium. As you can see, wherever the star sign, I am in the particular machine. So this is Cilium agent, or I would be in the master node, depending on the command which I would run. Yeah, so we have run few commands here. So as you can see, there are different resources, what has been added by the Cilium installation process. They have been added here, which are the Cilium network policies, identities, endpoints, and so on. These were not earlier. Now they are there in the system, right? And similarly, I can check out different CRDs data here. What are CRDs created? Guys, am I audible to you?
Yep.
Okay. Something, okay. Yeah. So now, as you see in the output, we get some different other information from these CRDs data what we have. So you can now see that there's something here which are something called as endpoint and identity, which we have not seen so far. So we're going to now look at this kind of information. What is an endpoint? What is an identity? What is the enforcement and so on? So we'll kind of cover these things now. Any questions so far? Okay. Fine. So similarly, now if I look at the CNI configuration there, which I was mentioning earlier, that as you saw the CNI plugin, it would get some kind of CNI configuration system here. If I go here, this is the CNI config data or the configuration what has been given to my kubelet node here, that you need to configure the CNI plugin and it would have a default configuration file to pick the data from, the information from there. Okay, so now this is the basic thing is being done. Let's look at some of the component what we have to understand here. Okay, so now let us actually deploy some application here and then look at something called as endpoint, identity, Cilium services, and policies. So these are the 4 core concepts which you need to understand to play around with the Cilium thing. Okay. So as we are close to 1.5, or do you guys want to take 5 minutes break and come back, or we want to continue?
Can take a break. That would be helpful.
Okay, so we'll come back at 4:30, 6 minutes from now, and then continue with our remaining stuff, like 5-6 minutes break. We'll be back pretty soon. Yeah. Fine. So I'll just quickly give you one more repo. I can actually, let's do it here only so that there's no confusion. So I hope you already have this link in front of you. And after the setup, what are the kubeconfig file I have? I'll just going to put up here now. So those are silly setup I would do, but deploying the application and so on, you can do along with me and do the hands-on lab as I would do, right? So that would be helpful. So what we'll do is we are going to share the kubeconfig file here. So what we'll be doing is, I think you're all running that previous lab environment, what has been given to you there, right? So we can just copy the kubeconfig file there, or you can have a kubeconfig file wherever you would wish, right? So maybe on a local laptop, if you have kubectl, you can copy the kubeconfig file there, or in this particular lab environment, which you are already using, you can do the kubelet or the kubectl installation there as well. So we'll do that in a minute. So I'll just copy the kubeconfig file first. So let me do that. Yeah, so wherever you are, so basically you can do something like this. On that environment, we can do like this. So copy this content in that, and then you should be able to follow along. So you can just, I just put the link on the chat again if you don't have it, the previous link. Yeah. You copy this entire stuff. Go to the lab environment, what has been given to you already. And we can do the things there, right? So was here from, yeah. So I'll just open terminal. There's also an ID, by the way, so you can open the ID as well, whichever you would wish. And let's just stick with the terminal for now. Now the kubectl is there now. So kubectl install, right? So kubectl installation should do as well. kubectl Linux. These two commands should be able to install kubectl for you. So I'll just copy paste the command here. Yeah, and if I do kubectl get nodes, I should get the nodes there. Yeah. So hope you are able to access the cluster in some way. Let me know once you are done. I'll just wait for a few minutes. Yeah, so we got from Anshul. Anybody else trying it out? I'll wait for 1 minute here. Please let me know once you are able to set up the, I think one more thumbs up I've got. Great. Avi has done. Abhishek Gupta has done. Sajid, how about you? Kings, how about you? Are you able to get it?
Yeah, done.
Okay, great. So now all of you are able to access this particular environment of ours. So now what we'll do is so we just have the, and you can see that there is Cilium node running. You can get to the nodes and even run some of the commands I was running. That's perfectly fine. But now what I'll do is I'm just going to go to the next step here though. So I'm going to set up something called as Hubble. Hubble is your UI, right? So we can, okay, one more thing what we can do actually, that would be helpful, that we can create our own namespace and then deploy the applications on that namespace as well. Correct? So that way, when we deploy the apps, we are deploying on our namespace, and whatever we do, our apps and our changes stay in the particular namespace only. Yeah. So what you can do is you can run the command to create a namespace and then update the kubeconfig file to work on that namespace only, right? So what we do next step here is, yeah, once this has been done, so what the next thing is, we can do kubes ctl create namespace, let's say Khare. You can do whatever change you want to have. And then in the kubeconfig file, in the context, we would put the namespace here, right? So that way, whatever the apps will deploy, they'll be deployed on our namespace only, correct? So let's do that particular change as well. So, so what you'll do is you'll create a namespace and update the kubeconfig file. So let me show you how that would be done. So you create a namespace here. So kubectl create namespace and Khare, or whatever name you want to give, and then update the kubeconfig file. In the kubeconfig file, under the context, you will put down the namespace here and give the namespace thing, right? So that way, whatever apps you are deploying, they would be deployed under the Khare namespace only. So kubectl get pods, of course, the thing is being deployed, but if I do, yeah, it says that, right? Nodes is deployed in the Khare namespace. Okay, great. So all of you have it almost, right? Good. So now we have got our namespace, we have got our things. Let me actually change on my environment as well. So when I connect to both, I'll connect by the same environment only. Great. Now this is being done. Now let's deploy the applications on our namespace. So there were two applications given on that particular environment. So in our shared page, you'll see that there are two apps are there. One is the front end and the back end app. So we'll just go and deploy that before deploying Hubble and all that stuff. So there is this back end app, and then there's a front end app. So you can just deploy both of these applications in your namespace so that we are good. And then we look at some of the next step of the labs there. Okay, so let's do it. So I'll just say backend.yml. I got in more automation, but could not get enough time. My backend is there. Then I'll deploy my front end app. Okay. Okay, so I deployed my front end as well. Okay, now we'll be running, of course, some pods there. Just check. Oh, what happened to my backend? I didn't apply it. 1 minute. And then, of course, if you have the service, you will have a node port also deployed there, right? So now what we can do is we can all find our node's IP and then access on the node port just to make sure that our app is running there, right? If I do kubectl get nodes -o white, I'll get my node's IP and then hit the port number 30687. In my case, you may have a different port number. So let's just go ahead and access whether we can go and access our application or not. What was the IP? 30. 30687 for me. 30687. Okay, all of you got the app running. Put some data into it, whatever you want to put up. Just make sure that it's working perfectly. All done, guys? So we have got Abhi, Anshul, and Khare. Abhishek and I think Kings can deploy as well. Let me know if you have any issues. Please let me know. Don't hesitate because it's a small group of people. We can spend some time and fix the problem if you are having, right? But better we do it in the right way. Yeah. Any problem anybody facing, deploy the applications. So we got one more person. I think there are 5 of us doing, right? One more person. Who is doing it? Anybody else trying it out other than 3 of you? Okay, let's keep going. So what has happened is we have deployed our applications, and now I want to talk about a few concepts here, which were endpoints and identities. So I just want to talk about that thing first, and then we'll jump into the Hubble part of it, right? So now let's look at how we can find out identity in endpoints there and services. Let me open the presentation here. Yeah, so now what we can do is we can actually log into the agent here, and in the agent we can run the command Cilium endpoint list. So let's just do that and then try to look at what are the information we are getting here. Okay, so let's do that. So what I want you to do is I want all of you to log in into the Cilium agent and then run the command Cilium agent list. Okay, or no, Cilium endpoint list. Sorry. So what we'll do is we are going to go to our environment here, find out the agent agent pod name there. So we can find out in the namespace of Cube system what is the name of our agent. Because we have a single node, we'll have a single agent for now. So Cilium -w5 GD7 is our agent name. If I do kubectl exec -it, the agent name, and you can do bash or shell, whatever you would wish. Okay, give a namespace name, of course. Yeah. So with this, you are going to get into the agent there. I'll put on the chat here the command because it'll be easier. And now here I would run the command Cilium endpoint list or endpoint ls or list whatever. So you can see here I have got this less command is on. I'll just do a head here. So you can see here. Let me do some more here. Head minus -30. So as you can see here, there is endpoint is being given, right? So endpoint number 3. So what you see in the Cilium thing, are you able to get into the pod of this? I hope you can. If not, let me know. So when you run the command Cilium endpoint list, in the endpoint list, and I just did a head here just to get the first 30 lines here. You can see that every pod what you have, right, or every pod in terms of Kubernetes is going to be given a unique endpoint ID. Correct? So that is again generated inside by the Cilium. And now this is what was mentioning in the slide deck there, that all application containers which share the common addresses. So again, a pod can have multiple containers. So for every pod, we are going to have an endpoint, correct? And this ID, what Cilium endpoint, it's unique in the entire cluster what you have, correct? Now, what you see further is all of these endpoints are going to have certain labels here, right? That is being given here, right? And KTS app, KTS again. So what is KTS here? This kind of giving you that it's a KTS. It is coming from the Kubernetes. So what happens is when you have Cilium and when you have, is anybody playing some kind of sound behind the scene? I'm hearing some. Okay, so what we did is we just kind of installed we just went into the one of the instance there, right, that's our agent here, and then we ran the command of the Cilium endpoint list. That is what the command we have done. So we are here, and then what we were discussing is every pod what we create, right, in the Kubernetes, it is going to get a unique endpoint, and that there are going to be some attached labels to it, and there is this source :key and the value. So this source I was mentioning about KTS as the source what we have. But suppose if you are deploying with containers or with just a Docker there, right? You may have a Docker as a source here. So that way, depending on the environment you are in, and if you look at these endpoints would have source in the beginning, and then you can identify this particular endpoint is coming from which particular orchestration engine and so on. So that kind of that's node which I wanted to share. Now, once we have these endpoints, the next thing becomes there is a identity. So now what happens is, as we look at the identity here, the fourth column here is of that, and this identity is kind of given to identify like a similar kind of objects together, and they'll have, like, if you look at in terms of uh, Kubernetes pods, right? And if these pods are going to have the similar labels, right? So there'll be different pods which are different endpoints, but if they share the common labels, right, they come under the same identity. So if I scale my deployment object, we would see that this identity kind of remains the same for the similar object there. So let's just try to do that. Let's just try to scale our front end here. So we have this deployment, which is, let's just say the name of it. So I'm in the other pod. Let me just go to the other. You'll see that for the how many, why they are coming. Oh, because now we have multiple people, right? That's why I wondering why there are so many RSVPs are there. Because we have the same agent here. So you can see that now the number of you have to identify which one for you, right? So I think with the namespace you can identify. Look at the labels here, right? Identify for a given label what is being given here, right? So like for example, for the Abhis or for Ansel and for K Saturthi, like we have a different namespace and then we have a same application there, right? You can see that there are now multiple RSCPs are there, and if you try to map, you will see that there are going to be multiple pods is going to be on the same namespace which I have, and they'll have the similar identity. So they have different endpoints, which kind of tells you that I have a service. For service, I can have multiple endpoints. That is what's meant here, correct? Any questions on this? Okay. Now, similarly, the way we have the regular Kubernetes services, we have Cilium services. Again, internally, they map to the same Kubernetes services if you look at. And if you look at now the command of Cilium service list, you will see this kind of listing where you'll find out what is cluster type attached to this particular pods there. So we have now 2 pods for RSVP. They will be listed accordingly. So if I go here and then run the command of Cilium service list, you'll see that for different pods what we are running for. If you try to find the IP address and so on, you kind of try to map it there. So if I look at, for example, in my case, kubectl describe service RSVP. Sorry, the spelling is wrong. You can see here, for in my case, my service IP is ending with 76, and then pods are 172 and 7, right? So if I go back, I should be able to find that for the service ending with 76, where it is, yeah, this one. And you can see that I have these 2 endpoints here. So it's kind of one-to-one mapping between the pods and the service what I have there. Any questions here? Are you able to follow? All good? Is you able to hear me, right?
Yeah.
Okay, cool. Fine. So any questions? Okay. Now, if you look at the Cilium policies, which we'll talk about next, you can see that the policies, if you look at the endpoint listing, they would be saying ingress and egress policies. They say disable, enabled, right? So currently we don't have any of the policy configured right now. That is why they are disabled. Correct. Now, what we'll do next is, now, as I mentioned earlier, let us now install the Hubble UI. So I'll do it right now because one person can install the infra part of it, right? And then of course I'll give again the same node port access so that we can all access the UI, right? What was given there. Let us go ahead and let me do that for you. I'm just going to install the Hubble, but the steps are given which you can try out later. So now I'm going to install this Hubble and make it available on the node port. So first of all, I'll download this Hubble binary, which you can do it, but otherwise it's not required all actually. I just go ahead and just install the Hubble software on my system, on the cluster what we have. So I'll go to the node here and I'll run the helm command again. Now what we said that I have enabled the Hubble and I also enabled the Hubble UI and made the Hubble service in the node port. That way we all can access it, right? So let's just wait for the service to be available and pods to be available here. I'll just do pod/services in the queue system. Yeah, so all of them pods are also running. So you will see that there is going to be a Hubble UI which is on 31235. So this node port is common for all of us. So again, we can find out our node's IP the way we have last one, and we can open on this 31235. So all of you can go to that RSVP application URL because it's a node port, so our IP of the node is going to remain the same. So we would copy the node's IP and then hit the node port. So 31225, right? I think something is wrong. What was it? 31235. Yeah. So you should be able to do something like this now. Correct? Are you able to see?
Yes.
So now you can go to your namespace because first of all, we can go to any namespace, but for now, let's just go to this is what we belong to. And you can see this, it will show you like this. Are you able to see the UI like this, what I have on the screen?
Yep.
Yeah, so you can see now the traffic is hitting to your RSC. So from the external world, you come to your front-end application, and then you access your database application on 270.174 port. If you go and refresh the page or put some entries in this particular page, whatever you want to put up, you will see that the respective data would come here on this thing, right? So you can see here, right? From the world, I have accessed the RSVP application, and then that data has gone to my backend and so on. Correct? I'll just wait for a minute here. The basic things. Okay, let's look at some theory part and then we'll do further hands-on there after this. So now, so there are two routing modes, what we have in Cilium. One is the encapsulation mode, another is the native routing. So when you configure the cluster and where you have multiple nodes running there, and you want to communicate between the clusters or between the different nodes of the same cluster, what happens is there can be a mode which is enabled, which is of encapsulation mode, in which we send the traffic over the VXLAN. This VXLAN, I believe you would be knowing that, but it is like going packet over packet. So what does it mean? That when the traffic is going from this pod, for example, if I send the traffic from this pod to the pod of the other node or other node in the cluster also, both you can think of the same way. So what happens is this particular pod is going to kind of build like a network packet, which is defining as source, destination, and so on. So what happens is this particular packet from this pod is going via the agent. So what's happening in this particular case, when the traffic goes from agent of this node to the agent of other machine, right? So they communicate among themselves, but inside that packet, there is a content. So if you think about this VXLAN ID, this payload is there. Now, this payload is nothing but the packet created by this particular pod. So you know that, right? When we send the traffic or the packet, which means source, destination, so we'll build like a network packet which would have source, destination, and data. Correct? That has been built for this pod, from this pod, this particular pod. That is going inside the agent packet. That's in the payload, right? That is called encapsulation. So you are sending data over data or packet over packet. So this may be a bit slow because you have to kind of encapsulate here and then decapsulate here. So this can be a bit slower. Second mode is you can go in the native mode where the routing table is configured at both the endpoints. So whichever traffic is not local, it would go via the routing table. So then in this case, the traffic would go from this particular pod to this particular pod directly. That is what we meant by the native mode, where these guys know that how to reach to the other pod and what route I have to follow. So that is by default given in the routing table of the given node, and based on that, the decision will be taken. So this is how it has been configured in the Cilium. Then for the IP address management, as we know, like for example, if you know that in Azure, right, you cannot have X amount, like, so in Azure you get, for every node you'll get some specified number of pod IPs, right? You can't go beyond that. So which means there is some way by which AWS is controlling how I would define IP address to my pods and so on, correct? So when you try to implement the Cilium along with, let's say, EKS service or somewhere else, right? You need to you can tell Cilium that how does the IP address management is going to be handled. And there are different ways it can be handled and different environments, as you can see here. So when you're configuring Cilium on the different cloud providers and so on, you can give this option that how the IP address management should look like. Like that way, if you recall, when we did the Helm minute, right? In that we mentioned about that CIDR, right? So similarly, when we are deploying this Cilium on different environments, we would give this CIDR value as well. And based on that, the pods are going to get the IP address accordingly. Hope it makes sense. Okay. Then here is a comparison number between the kubeproxy performance and the eBPF performance. This data I have taken from the Cilium site itself. So as you can see here, the latency which is lower is better for us, right? So as you can see here, as we add more number of services in our environment, so for a smaller one, you will not see much of a difference. But as you create cluster size increases, as you add more services, you can see that the latency of the eBPF is almost constant, correct? Which is 300 millisecond or microsecond here, correct? So that way, you can see the performance gain you're going to get if you deploy Cilium in the large or a bigger cluster there. Any questions here? Which I talked about already. How does it happen in the previous thing we discussed already? Okay, now when you are configuring the kubeproxy, so kubeproxy by default comes with Kubernetes installation, but with the Cilium installation, you can either have it, not have it, or partially you can have it, and so on. There are different modes are there: strict, probe, partial, and disabled. So depending on that, what you will choose, your system would behave accordingly, and the performance benefit would come based on the situation what you have chosen there. Okay. Now let's look at some of these network policies which are very interesting, and they're very powerful over the basic policies what you have there in the environment, right? So now, these are basic policies, or this is a policy of the Cilium given here. So in any of this policy, when you create, right? So what you can have is you can expect the endpoint selector and the node selector. So what you are seeing here, like in this particular policy, I'm giving the spec. In the spec, I can define description, endpoint selector, ingress or egress. Then of course, I'll talk about labels and the other things as well. So this is a sample policy which I have given here, and then we look at some of these policies with hands-on here. The description, what we mentioned here. So endpoint selector or node selector means that for which this particular policy you want to put in place. So what we are saying is this particular policy we are putting for all the pods which are having a label env prod, correct? And then we are putting the ingress. I want to allow the ingress communication from all the pods which have a label env prod. So I'm saying in a way that I am trying to connect among ourselves only, say that in the same environment there. But let's look at some other examples here. So we can have the layer 3, layer 4, layer 7 or host policy. So these are very broad and then very covers almost all the cases what we may have in our environment here. So in the layer 3 based things, like in this case, we can pick up the combination of service name, labels, IP address, and so on. They'll come under the layer 3. In the layer 4, we'll put up the port number, the protocol which you want to use. In the layer 7, we can have HTTP based. And the host policies is the way when you're configuring network policies with respect to the given host. So for example, I want to allow this particular pod to access all the hosts available in the same network, or do I want to allow this particular pod to be accessed from public, or send the outgoing traffic to public world as well, and so on. We can configure those kind of host policies as well. So with this information in hand, let's try to now look at some of these policies and then try to do the hands-on with that. So let's see the first policy which we want to implement. Let's say what is happening now is, let's say, yeah, this is our connections. This is going through. Oh, okay. So let's just try to first make a policy, and let's say, let me actually get my from the other environment which I'm experimenting. Let me just get a policy because they kind of follow a sequence there. So I'll just mark this on. Yeah. Actually, here I'm just kind of experimenting with simple policies here. Yeah. Let's do one policy here first of all, in which I want to make sure that the connection to the backend pod comes only from the pod which is from the RSCP, right? So I want to make sure that only this particular pod or this kind of pods can access my database, nobody else can, right? So let's try to build that policy, and then what we'll see, how does that going to affect, right? Let me copy this policy and give it to you guys as well so that you can try it out as well. So you can give it any name to it, and then we give it a shot. So on the same shared pad, where is it? Yeah. Actually, let me go towards the end to do it rather than putting in between. So I'll just go towards the end of it, of the page, line number 405. Why this? Something like this. Yeah. Okay. You can give any name to it, doesn't matter, but to put this policy in place. Yeah. Why it is like this. Yeah, whatever. So something is wrong, but hope you got the thing right. So you just copy this particular data from here, and let's create a policy and then execute it. Correct. So let's just put the policy here. So we can say policy 1, P1 dot whatever name mode, it doesn't matter. Paste. Yeah. This policy, as simple as says, it's saying that what I am saying is for all the pods which are having the label app is equal to RSDB. So if I look at current pods there, so if I do kubectl get pods, show labels, you can see here our pods have different labels here. So what we are saying, for all the pods which have a label RS app to RSDB, this the backend here, these pods, for them ingress, the incoming connection can only happen from the pods who have the label app is equal to RSDB. Correct? That is what it means, that you are allowing the backend to be accessed only from the front-end application. That is what we are trying to configure here. So let us apply this policy here. Yeah. This policy is created, and we can describe this with kubectl describe. Short form is CNP, Cilium network policy. So describe CNP. The name was L3-root. So you can see that this particular policy is applicable for the Khare namespace. And then this is how it's been done. Yeah, questions? Yeah, it is namespace, as you can see here, right? You can have a cluster-wide policy also, that is a different thing, but currently we are discussing the namespace-based thing. Yeah, have we done that?
Yes.
Yeah. So now this is perfect. So nothing will change right now. Our application is going to work as it is because we have configured the right way. But now what is the point? Now what we'll do is we'll create another pod, and from the other pod we'll try to access the backend and then see what happens. Right? Let's create an Nginx pod and then try to access the application on that pod. Right? So let's just do that. So I'm going to create a pod here. So kubectl run Nginx image Nginx Alpine version and sorry, we haven't done that. So kubectl delete pod. I shouldn't have used this hyphen, but I'm making it effect. Yeah, so I deployed a pod here, and if my pod is running, yeah, so let me go to the pod here. So kubectl exec -it Nginx, and the command which I want to run. Sorry. So these two commands I have run. So I just ran this command to run the pod. I'll put it on the shared pad. Why this is behaving like this? I don't know what happened. And then exec. And from here, now try to access the backend pod and see what happens. Yeah, so now what we'll do is from here, so currently if I look at the Hubble, let me just refresh it and see if our new pod has, okay, it is not come in the picture right now, but let's just try to access and then see what happens here. So I'll do now curl MongoDB. That's our service name. We'll do the port number, right? So this will work 27017. Yeah. So you can see now, I have got this particular request now. This is being dropped now, correct? As you can see here, right? What I can do is I can, on the top, I can say verdict only dropped here. And you can now see here, I'm getting that dropped request here. So now what is happening is, so I'm not given any app name here. That is what's kind of telling us nothing is not unknown app. But as you can see here, I'm trying to connect, and this gives us right particular part. It's a dropped message for me for now, which means I cannot connect. Correct. And if you remove the network policy, it would start working. So if you remove the policy, you can experiment that it would work out. Are you able to see this behavior?
Yep.
Hopefully others are able to do it as well. Okay. So now this is one part of it. And then if you remove the policy, so let me, if I remove the policy, so kubectl delete cnp, what was it? L3 rule, right? Yes, if you remove the policy now, and if you now exit, I can try it out, it would work now. Let's see, it's kind of giving the message. So I mean, of course, we don't have a MongoDB driver, but you can see the thing, right? That it is giving the message and it will to connect. So if I go back here, you'll see that it would be able to connect now, and we are good. Yeah, less than 10 seconds. RCPF, but no app also works, right? So this is also fine. Okay, all good, guys. Should we move on? Okay, so we look at the next policy now. So now similarly, the way we have this ingress policy, I want to show you with the egress policy also. Let's try that and then see some difference now. The second policy now. Okay, so you can give it a second policy and then apply it, and then see if after this you are able to access your front end or not, right? So what we are doing this policy is we are saying that for all the pods which are having the egress policy, which is app is equal to RSCP. So basically, we're saying that for all the front end applications, make the outgoing connection to the endpoint, which is having a label role DB is equal to RSCP DB. So we are saying that front end can talk to the back end, correct? So let's apply this policy here, in which we are saying that front end can talk to the back end. That's perfectly fine. So I'll just give it p2.yml, put my stuff in place. Not here actually, do it here. If I do it, p2.yml, put the policy in, sorry, set, paste. Yeah. Now the policy here, as the policy says that front end or talk to the back end, right? So perfectly created. So you deploy the policy and then let me go and refresh my front end page and see what happens. There seems to be some issue there, right? My front end can talk to the back end now. So as you can see here, with this policy, there's something wrong, and our front end cannot talk to the back end right now. Though our policy says very clearly, but you can see here, it is all giving me dropped thing here. It's not giving me the forward message, but dropped. Any idea why it is getting dropped message? Why I cannot talk to the backend? Though our policy clearly says that in this policy, I'm going to allow the front end to the backend. So we are saying it very clearly here. But what is the missing piece here? Any idea?
Front end cannot talk to the world.
No, we don't have to talk to the world. So world is fine. So we are saying that, okay, so no, even if you do a curl from the pod itself, right, it would still fail. So what I'm saying is if you go to the front end pod, try to connect to the backend, it will still fail. And yeah, any reason? Do you know why it is happening?
Right service level.
Come again?
We need to mention the right service level.
That is correct. So all that is correct. So if you look at here, again, we are not mentioning by the service name, we are doing by the labels now, right?
Is that default? It's going to block the backward connection, like the reply.
No. Why it would say, we are saying it very clearly that it should connect, right? So we are saying that application which has a front label app is equal to RSVP, correct? It's a front end application. Would talk to the backend here, which is the role DB, RSVP DB, correct? Perfect. There is no problem with the rule per se here. So it should connect, but there is something very basic which is missing here. I just want to make sure that you put enough effort to understand that particular point. Very important.
Namespace missing?
No, it's the same.
No, namespace is there, right?
Yeah. It's a very basic thing. I mean, this is like very fundamental things when you're deploying on Kubernetes. You should know this part particularly. Anything? Okay, let me give you a guess here. So let's schedule the pod and try it out. So if I do get service. Yeah. Now let me get into the pod of the thing, which here exec -IP pod. Yeah, okay. So now here curl, hopefully I have it. The curl is not found. Telnet is there. Okay, so telnet is there. Okay, fine. So telnet, and if I use the MongoDB and the port number 27017, This is going to fail, correct? But on the other hand, if I give the service IP address here, okay, it is still failing. Okay, something is magic is going on. Okay, fine. So telnet is working. I'm not too sure, but you
does
got
DNS?
you got the hint. Yes, correct. That's the hint. That's the hint, right? So if you look at here, so if I kind of go and try to look at the visually, so if I look at visual, and there is one option to come to check it out. So if I say kubedns, so as you can see here, the kubedns is being not allowed. So because in the policy, what we said that allow the traffic from this particular port. So if you go and look at the policy again, correct? For this policy said that for the all the ports which have a label app is equal to RSVP, send the outgoing connection only to the backend part. But as you know that when you are talking to the backend service, right, you need to give the DNS name. Typically, you use the name for the service, which means it has to talk about DNS as well. Correct? Make sense? So that we need to allow our front end talk to the to talk to the DNS along with the backend service. So that is the catch here. Understood? Is this point clear to everybody? What happened? Anybody has any doubt that what was the problem? Yes, please let me know. Everybody is clear with this? What was the problem? Yes or no? Yeah, okay, thumbs up. Because I could not see thumbs up, so I'm just asking it again. Okay, fine. So now the way you can resolve it is by putting up this particular thing. So what we are saying that now, when you put a policy in place, you would do it also for the DNS as well. So as you can see now, this is a new policy which I'm going to put up here. In this new policy, what we are also adding that, let me just add actually here. So I'll just update that same thing here. So now here I'm going to add another match label here. Just make sure that it kind of go in the right thing, right attachment. Oh, this is good up. Let me just copy one completely. So now as you get this particular policy, this kind of policy you cannot write in the regular network policies in Kubernetes, right? Because they don't understand all of this kind of a say at the lower level of Kubernetes objects like this, like the way the policy we are writing in Cilium, right? As you can see here, it can match very clearly that you are going to the namespace level as well, right? So KTS IO names Kubernetes.pod.namespace kube system, and this is the service name. This kind of pinpointing to the applications or things are not possible. Okay, so Abhishek missed it. Okay. Okay, so thing is, okay, let me explain that. So what happens is when you deploy the Kubernetes cluster, correct? What happens is there is an internal DNS server which gets created in your namespace of kube-system. So now why we need a namespace, as you may know, right? So namespace, DNS is being used to basically resolve the name to the IP address. That is clear, right, Abhishek? That like the way when we open a website, we open like with the DNS name. Okay, got it, right? Okay, fine, great. So that was not, so we are not made it available from our front end point. That was the problem. So that is the default policy when you are kind of configuring the egress connection, make sure that you allow the traffic to go to the DNS, otherwise the resolution would be ineffective. That's what happened here. Okay. So now let's apply this policy here. So we can remove the previous policy and then we can apply this policy and it will work now. So let's just go ahead and do it. So we'll just remove that policy. Correct. Applied. And now it would start working. Yeah, it's working all right. That is how we can do the things. Okay, so last policy we look at now is the layer 7 based policy. Okay. This is the policy what we are putting right now. This is again a policy. So you can read me and tell you what is it. So anybody can try to explain what is we are trying to configure now. So take a look at this particular YML file and then tell me what we are trying to do here. Sorry. Yeah. Any guess what you want to achieve here?
Application and some through
Come
application.
again? Go ahead.
We
Be
are
louder.
creating a rule to allow only layer 7 only HTTP
Correct.
kind of traffic we are allowed.
Correct. So now what is happening, as you can see now, this is another level. Again, we're deploying the application with Cilium. We can have this kind of feature, which is not possible with just a network policy, what we have in Kubernetes. So what we are doing here is we are putting a policy in which we are saying that we are going to put a label again for this is going to be applicable for front-end applications. And we are saying allow only to the put rule. So basically we have different API calls or the different HTTP thing, right? So we are saying only allow the put. So we are not allowing the get here. So what will happen is once I apply this policy, our website would not be available because we have configured the put policy only. So this is only going to allow the put, not the get call. If I apply this policy now, so we just remove the previous one. I'll share the policy on the chat in a minute. Yeah, this has been created now. And now if I go and access the page, go to throw an error for me. Access denied, correct? So what I have done is because I said that I want to allow only put, there is no get has been allowed here, correct? So I cannot list the page. Of course, I can configure to allow get and not do put, but what we have done is not to allow the get operation. So that way my page is not available to me. So again, this is again a rich thing what Cilium can give us. It's again a very much for security purpose. Hope this makes sense. Any questions?
So I'm just wondering about the HTTPS.
Same thing, right? HTTPS, same, I believe, right?
Okay, it's not going to look at the payload, just the.
I don't think so. It's a HTTP call which is going to be common only for both of them. It's just that HTTPS is secure, but I don't think it's a make a difference. That's what my understanding is. Yeah. Okay. Fine. So that is the other one. Let's look at a few more things in the slide deck now. So hope all of these things again. It's a very powerful thing what Cilium can allow you to kind of do that, achieve this. So we talked about these policies. Then what can happen is the traffic between the Cilium managed endpoints and the host can be encrypted by default. So basically, you can use this IPsec or WireGuard thing as a part of the Cilium, and that way the traffic which is going between two endpoints or two nodes and so on, it would always be encrypted. So that's again another security feature which you can get at a very low cost. The next here is something called as multi-cluster or cluster mesh. So what is happening in this particular case, as you can see, we can connect two different clusters and have a one complete control view of it, the entire thing. So the use case of thing you can think of that way. Of course, it's a high availability stuff, right? You can have one cluster on or two different clusters can be of different on different cloud providers. Then what you can do is we can also have a shared service, let's say Vault, and then Vault can be created once and available on multiple clusters. Then similarly, we can, let's say we have one stateful cluster, one stateless cluster. So we can also put it like that, that maybe we can have all the stateful infrastructure on our local on-prem, and then we can have the public-facing stateless workload on the cloud. So all of these things are possibility with the Cilium cluster mesh. That is the policy with that. Then along with that, we now have this Cilium service mesh as well. Now, what this particular thing is about is that if you have been following the service mesh ecosystem, primarily it has been implemented by sidecar proxies. So, like for example, in Istio, not talking about the latest thing what they're building up, but the regular Istio what we have. So you basically deploy a sidecar container along with each application or each pod. And if you have lots of application, you are deploying one sidecar every application. And that may be kind of, that may become very, kind of not very scalable, and there would be performance overhead, and people have seen that, right? So what with Cilium we can do is we can kind of have um, the Cilium. Of course, it can work on both ways. One is existing Envoy sidecar method, that is one, or now what we are coming up with Envoy sidecar free service mesh, in which what happens, we deploy an Envoy per node. So in the previous case, it was deploying one Envoy sidecar with per application. That is very expensive. Then comparing to eBPF and deploying Envoy on a single node, correct? So if you have 5 nodes, we deploy 5 Envoys, one on each node. That is how the service mesh is very evolving in the Cilium ecosystem as well. That way, this is how the Cilium is using the eBPF technology to kind of achieve all of these things. Hope it makes sense to all of you. Any questions you have? Okay, now that is one of the use case. Let's look at one more use case of the Cilium part, not Cilium part, eBPF part. So I mentioned about now again, eBPF is a general technology which is part of the kernel. Cilium is one of the user of it, right? And there can be other users from different perspectives. Let's talk about one perspective from the security perspective further. So this is Cilium, and this is how it is using the eBPF to make the network faster. Correct? Questions? Does it have a compliance issue? So no. So see, again, this is becoming part of a kernel, so it is transparent to any end user per se. So we're talking about Cilium or eBPF in general, Abhishek? Abhishek, talking about eBPF or just the Cilium? eBPF by
I mean, the Cilium.
compliance issue I have not seen, but I mean, I'm not
Like for
like
PCI DSS and those stuff. I mean,
uh,
I've seen some of the networking solutions that we have. Those got rejected because of
that I am not
the
too sure
compliance.
right now. I don't know. So you can just PCI, which PCI compliance, right? PCI,
Yeah, PCI DSS.
PSI, PSI,
DSS.
DSS. This one?
Yeah.
I think in their isolate site it is mentioned that it is
It is
DCR,
okay. Then
GDPR, PCI DSS, ATM security, and all those things.
Okay. Then I think it is there. So Cilium has two, of course. Cilium is a open source project. Then they have Isovalent company. Isovalent has some additional features on top of it, which is paid solutions. So of course, I mean, they definitely have a PCI compliant stuff. So I think we are good there. And Cilium would be there as a part of it as well. It would be compliant. Okay. So the next part, which is talking about, yeah. So I talk about the other use case of it. So one example I'll talk about now, Falco thing. So now Falco is, so as I was mentioning earlier, right? The Falco is the tool which was kind of which is used by Sysdig for the runtime alerting and security thing, right? So for the runtime security, we use Falco a lot, and then Sysdig is the company behind it, right? So Sysdig, or when the Falco was earlier released, they kind of built their own kernel module to achieve the way of system call. So Sysdig company was built to kind of in a way look at all the system calls what we have. And what is happening system calls, it was trying to kind of trying to read the system calls and give you security measures, what is required. That is how the sysdig company has come. Sysdig system call dig, right? That is what the thing is. So that's when they kind of published this Falco open source project, which kind of does part of it. And then again, it kind of try to look at system calls what we have and try to figure out what is happening and then try to give you the answers or the alerting based on the rules what you put up, right? So earlier it used to build by the kernel module what they have built entirely, but now they are shifting towards eBPF probe method. And if you look at their documentation, they'll say that use eBPF as a by default solution other than going with the kernel modules, because eBPF is again part of the mainline kernel, so it is well tested and it is, as I mentioned earlier, it has a verifier. So whatever things we'll put up in the kernel, it's going to be verified completely that it doesn't break your kernel. So even they are saying that use eBPF as a default one. So what they have is, so first of all, system calls when they call, Falco is kind of read that thing. And then there's a rule engine, what they have. Rule engine is kind of tell us like, again, the same way, right? If somebody does this thing, tell me, kind of a thing, right? And then once you have the data from all the machines and so on, you can ship it to the Falco sidekick, which is like a centralized way to put up all the alerts from different machines and then tell it to the user by the Slack or email and so on. That is how the sysdig is there. So now we'll look at the demo of this the Falco on the system, and then again the similar way the way we saw previously in the eBPF basic way. Here again, Falco is using eBPF to kind of probe on a given system call what we would mention it, and then it is going to give us the alerts from there, right? So again, you can deploy based on as a Kubernetes thing, or you can deploy per node. So currently, because I have a single node cluster, so we will deploy on a single node. So these are steps are there. This is going to kind of get the all the setup of Falco service on a system. So I just run this command and then let this command get finished. Now what we are doing here is we are putting a custom rule here, and the custom rule what we are putting is that if somebody opens up a shell, so basically the rule we are putting it run shell in container. It's like any name you can give here. And the way we are kind of going to catch it is like this here. Yeah, like here. So we are going to catch it like this. If it is not on the host and the service name is bash or any other shell equivalent, then kind of give me the and what it says that so description, a shell was spawned by the non-shell program. Yeah, so non-shell program. So basically, if a non-shell program spins up the shell inside your program, then you have to kind of tell me about that, right? That is the rule what we are going to put up here. Let's see if Falco is up. If Falco is up on our system, we'll create this particular custom rule file. Again, I'm not going too much of detail in the Falco, but hope you get the gist here. It's the same, right? So this is for the sudo. As you can see, the sudo program is here. Similarly, you can write for sudo here. We're going to write it for our this particular rule here. I'll just copy this rule. I think it has to align to the left. So rule, description, condition, output, and so on. It should be fine. I'll just restart the Falco here. Restart. System CTL read. Okay, sorry. Yeah, so I just did a restart of Falco. I'll just see the status of it, whether it's running or not. It is now in the running state, right? Now what we'll do is we are going to just create a simple program and try to get in the shell here. So what I'll do is again I'll kind of go to the other machine here, agent. I'll exit from the agent. Yeah, and I'll do journal CTL minus FU Falco. Okay, hopefully it would work now. So if I do kubectl, we already have a pod running there, right, of Nginx. Yeah. So if I do exec into the Nginx pod, exec -it Nginx shell. What happened? It actually report, right? It's running. Falco, right? This is fine. So it's the application called directly, right? Not comment, right? Okay, so let me do one thing here. Let me just check my other documentation, which I used previously. Okay, so this is the same thing, right? What we are doing. So we are running a pod here. What happened? Same machine, right? What went wrong? What went wrong? We installed these packages. Falco was running. Status is true. We got a file created. We did it right here.
We are using different units. We are using engines help in
Alpine version, okay, yeah. But that should not cause a problem. Okay, let's just try that also. But I don't think there's a problem per se. So kubectl, let's just give the name to the pod here. The journal CTL is log. I mean, it is not coming for the Falco itself. That is the problem actually. So the log should come anyway, right? So that is the main thing.
Can you check the Falco rules again?
Come again?
Can you check the Falco rule again?
Can I say the Falco rules file, right?
Indentation is correct.
Yeah, otherwise we'll give an error if it will not start actually if I give it wrong. See, if I give a different thing, right, it's going to throw an error. So if let's say if I just add something over here, right, it throw an error. So if I just CTL restart, did I restart? I did restart, right?
Yeah, you do.
Yeah, so if I made some mistake there, right, now let's see. This is actually giving me an error in the morning today when I was trying. Yeah. No journal found fine. This shouldn't be a thing. I should have got it. SystemCTL status. What is that? Journal D, right?
So just executing journal CTL gives something without any unit.
Right, journal CTL. Okay. No, nothing is.
Yeah, that is, yeah. So then
So there is something
maybe
is logged. Let's check the message. Starting capture.
it should
Also
do
not
message
coming.
here.
There's something the way by it is being called. So, yeah, driver is loading, unloading. This is fine. Where are the message going? Because see, Falco, once you have an issue, it does not actually do something, it just kind of gives you an alert. That is what does this. The general CTL itself is not working.
Yeah, I think maybe EDC systemd-general-d.conf may give it is giving any persistent.
It does something. EDC system.
General.
System. Okay, is there generally is there? Right? What is this one?
It is storage.
But how does
auto.
disable everything? Everything is disabled. For what reason, I don't know. So generally,
You can,
something else would be there. Yeah, go ahead.
Yeah, so I think the default is storage equal to auto. I think that is these are the defaults probably. Maybe uncomment and see if it is.
I just
Because
check
the file needs to be created in a persistent way.
Yeah, I just check one other thing and then see if it's something is coming. What's the service name? Oh, there's no service name not given here. System CTL. Configuration system D. What is it? Funny. Just need to kind of get the message. If it is not coming on the journal, it should come somewhere.
It's a systemd unit file, right? So we can add a systemd dash journal D.
Systemd.journald. Let me just check on this site on the other machine if I have. Yeah, it is coming here. So I think I'll just skip there. I'll just show the message to us, just show you the here. I don't know what is the problem here, but let me just show it to here. Yeah, so I'll just try this lab in the morning itself, so it shouldn't be a problem. But I don't know what happened in between. So journal CTL FU Falco. This is here. Now if I try to spin up a new pod here, we already in the pod running. So CTL get pods. Yeah, so let's just try to exec into it. And if I do it, you can see this message comes like this, right? That you kind of try to kind of get these kind of messages. So again, the core thing is eBPF, what is happening behind the scene. And with the help of whatever is Falco, we are trying to put a hook on that particular check, right? System call is being called. And if that is being called with the given shell, it gives a message back. And you can see here it's kind of even telling you what container ID and the image ID is being used. So it can kind of connect back to your Kubernetes objects and so on. And that makes things very powerful, correct? So yeah, that's what that's what it is here. Any questions? So I hope you have got the idea, right? That powerful of what powerful the eBPF is now, right? And then it is going to kind of change the way we kind of do the security and observability and all those things, networking, right? And it is really the kind of a next tech. Again, these kind of techs are kind of hidden from the end user per se, so you may not find enough users to kind of using it, like the way even we saw that today's session, right? A lot of people did not turn up because of the, I mean, kind of these are hidden things, right? But they're important as an SRE, as a admin, you to understand these things. So that is something which I think which is very much coming up and then very powerful, and it kind of being hidden is a better thing also, because end user don't care about it. They'll get some kind of user interface where they can see all the graphs and so on. That is what is important as well in a way. Yeah. So I think, yeah, that's what I want to kind of share. Hope you liked the session and it was useful for you. Any comments, anything you want to share?
Nothing. Thanks for creating the labs. It's very useful doing your hands-on.
Yeah. So there are others, not just one. If you can look at, there are other labs are also there. If you look at, there are a lot of Argo series and there are other workshops. And I mean, we have been having authors across the globe who have been writing the content on that. So if you and anybody else want to kind of put the content, share with the world, perfect. That is also good. Yeah. Okay. Thank you, and hope all of you are joining the KCD Bangalore 2nd and 3rd. Looking forward to see you there. Yeah. Okay. Yeah. See you guys. Have a good weekend ahead.